Hi, today we are going to be discussing system of equations. We have given a pair of equations. Let's call this equation 1, EQU for short, x plus 4y is equal to 17. Now we have two variables or unknowns in this particular equation, so there isn't enough information to solve for either x or y. But we are given a second equation we have 2x plus 4y is equal to 22. And we are told that these two equations are related to each other. So since we know these two equations are related to each other, we can manipulate them in such a way that we can cancel out one of the variables and then solve for the other. So this is type 1 system of equations where the equations already look similar. So if we are examining the equations, 4y they have in common. So we have to decide whether we are going to add the equations or subtract the equations. Now since both terms that have 4y are positive, then we should subtract the equations. So we can say equation 1 subtract equation 2. So we get rid of the y's. So x subtract 2x is negative x. 4y subtract 4y is 0. 17 subtract 22 is negative 5. So we have negative x is equal to negative 5. We divide by negative 1 to make x positive. So x is equal to 5. Now we know what one of the variables is. We can go back into any one of the equations and solve for the second variable. So let's choose equation 1. Replace the value for x. So 5 plus 4y is equal to 17. We subtract 5 on each side. So this cancels. We have 4y is equal to 12. We divide by 4 on each side. So we get y is equal to 3. So our solutions, x is equal to 5 and y is equal to 3. Let's try another example. Two t plus 3q is equal to 35. And we have 2t subtract q is equal to 15. Now again, the equations, this is equation 1 and this is equation 2. They are related and they look similar. So they share 2t. and both terms are positive, so we can subtract equation 1 and 2. So equation 1 subtract equation 2. 2t take away 2t is 0. 3q subtract negative q. So the negative and the negative becomes a positive. So we have 3q plus q is equal to 4q. And we have 35 subtract 15 is equal to 20. So we have 4q is equal to 20, so we divide by 4 on each side. Q is equal to 5. Now once we know q is equal to 5, we can go back and solve for t. So let's solve for t. So two t, and we're going to substitute the value of q, which is 5. 3 times 5 is equal to 35. 2t plus 15 is equal to 35. We subtract 15 on each side. We have 2t is equal to 20. Divide by 2 on each side. T is equal to 10. So our solutions are t is equal to 10 and q is equal to 5. Let's try. Type 2. Now in type 2, one equation can look similar to another equation if you multiply by a factor. So let's try equation 1, x plus 3y is equal to 8. And equation 2, we have 2x plus y is equal to 6. Now, we can either try to get equation 1 to look similar to equation 2, or equation 2 to look similar to equation 1. So let's try to get equation 1 looking like equation 2. So I'm going to multiply to get rid of the x. I'm going to multiply 2 times equation 1. And we're going to call this new equation equation 3. So 2 times x is 2x. 2 times 3y, 6y. And 2 times 8 is 16. Now we are going to subtract equation 2 from equation 3. Equation 3 subtract equation 2. So let's write equation 2 below. 2x plus y is equal to 6. And let's subtract them. 2x subtract 2x is equal to 0. 6y subtract y is equal to 5y. 16 take away 6 is equal to 10. And if we divide by 5 on each side, y is equal to 2. And once we know y is equal to 2, we can solve for what x is. just substitute. So let's choose equation 1. X plus, we replace the y with 2, is equal to 8. This is equation 1. X plus 6 is equal to 8. We subtract 6 on each side. X is equal to 2. So our solution set is x is equal to 2, y is also equal to 2. Okay, we're going to do another example of type 2, system of equations. So, after analyzing equation 1 and 2, we can get equation 2 to look similar to equation 1, so we can cancel the 5 t's. So let's multiply equation 2 times 5. 5 times equation 2, and we call this new equation 3. 5 times t is 5t. 5 times 2k is 10k. And 5 times 8 is 40. Now we can take away equation 1 from equation 3. So let's do equation 3, subtract equation 1. Since we already have equation 3 here, we can just write equation 1 below it. 5t plus 5k is equal to 25. We are subtracting these equations. 5t take away 5t is 0. 10k take away 5k is 5k. 40 take away 25 is 15. So we have 5k is equal to 15. Divide by 5 on each side. We have k is equal to 3. So since we know k is equal to 3, we can substitute into either equation 1 or 2 to get the value of t. So let's choose equation 2. T plus 2k, and we know k is equal to 3, is equal to 8. T plus 6 is equal to 8. Subtract 6 on each side. T is equal to 2. So our final solution set, we have k is equal to 3 and t is equal to 2. Type 3 equations. So, equation 1, you have 2x plus 5y is equal to 33. Equation 2, 3x plus 4y is equal to 32. Now in type 3 system of equations, the equations don't look like each other in any way. So we have to look at their coefficients and try to think of a common multiple. So if we look at 2 and 3, a common multiple of 2 and 3 is 6. So we have to try to get 2x to look like 6x or 3x to look like 6x. Common multiple of 5 and 4 is 20. So we could either try to get 5y to look like 20y and also 4y to look like 20y. So let's go with trying to look like 6x. So we're going to take equation 1 and multiply it by 3. So Equation 1 times 3. Let's call this equation 3. 3 times 2x is 6x. 3 times 5y is 15y. And 3 times 33 is 99. Now, we have to get 3 to look like 6x. So we can say equation 2 times 2. And we call this equation 4. 2 times 3x is 6x. 2 times 4y is 8y. And 2 times 32 is 64. So now they look similar. Now we can cancel out one of the variables. So let's do equation 3 subtract equation 4. 6x take away 6x. That gives us 0. 15 subtract 8y. That gives us 7y. And 99 subtract 64. That gives us 35. So now we can divide by 7 on each side. We have y is equal to 5. Now that we know what y is, we can go back into any one of the 4 equations and figure out what x is. So let's choose equation 1. So we know y is equal to 5. 2x plus 5y, y is 5, is equal to 33. 2x plus 5 times 5 is 25, is equal to 33. We subtract 25 on each side. We have 2x is equal to 8. Now we divide by 2 on each side. We have x is equal to 4. So our final solution said y is equal to 5, x is equal to 4. Okay, let's do one more example of type 3. Equation 1, we have 5a plus 2b is equal to 11. Equation 2, we have 2a subtract b is equal to negative 1. Again, the equations do not look similar in any way, so we have to look at their coefficients and see if we can get them related to each other. Well, a multiple of 5 and 2 is 10, and there's no number here, but it's understood that the coefficient of 1 is 2. So a multiple of 1 and 2 is 2. So let's try to get 5 and 2 to look like 10. So let's multiply 2 times equation 1, and we call this equation 3. 2 times 5a is 10a. 2 times 2b equals 4b. 2 times 11 equals 22. Now we multiply 5 times equation 2, and we call this equation 4. 5 times 2 is 10a. 5 times negative b is negative 5b. 5 times negative 1 equals negative 5. Now we're going to subtract equation 4 from equation 3. So let's do equation 3, subtract equation 4. 10a, take away 10a, gives us 0. 4b, subtract negative 5b. Negative and the negative becomes a positive, so we have 4b plus 5b gives us 9b. And then we have 22 subtract negative 5. Again, the double negative becomes positive. So we have 22 plus 5 is equal to 27. We divide by 9 on each side. We have b is equal to 3. Now that we know what b is, we can go back into any one of the 4 equations and figure out what a is. So let's choose equation 2, since it looks the simplest. We have equation 2, 2a, subtract, we know b is 3, is equal to negative 1. So we add 3 on each side. 2a is equal to 2. Divide by 2 on each side. We have a is equal to 1. So final solution set, we have a is equal to 1 and b is equal to 3.